All right, so this is the beginning of chapter 7, and it is video 6. And we're going to spend quite a bit of time in this section. So this is all about trig identities. And you need a little bit of information, a lot of bit of information on how to manipulate trig functions, really. So this first section, I'm nicknaming this 7.1a, actually. So this is all about algebra and trigonometry. Okay, so what we're going to do first is talk about how to FOIL in trig. Then we're going to talk about a bunch of factoring in trig, and then a little bit of other things. And throughout some of these, you're going to see some of the trig identities that we talked about earlier in chapter 5 come back to play. So we skipped chapter 6, by the way. That's all about graphing trig identities and trig functions, and we don't really need to, I don't think you need to do that. Many of you, it's never going to be important for you. So anyway, all right, here's what we're going to do. The first thing we're going to do is multiply cosine theta plus 2 and 3 cosine theta minus 1. And I don't know if this came up before, but if you see something cosine squared theta, that's the same as, in your mind, cosine theta squared, right? Like x squared, cosine theta squared, but the squared goes in between the cosine and the theta. So you want to write that this way, not this way, definitely not this way, because that really only indicates the theta would be squared, not the cosine would be squared. So you're not going to write any of those guys, all right? When you write, like when we multiply this times this, we're going to get 3 cosine squared theta. So 3 cosine squared theta. That would be the right way to write that out when you multiply those two things together, okay? And then you're going to have a negative cosine theta. I'm going to erase some of that stuff I just plopped over there so it's out of the way. And then we are going to multiply these two together, and that's going to give us a 6 cosine theta. And then a negative 2. So again, just learning how to combine like terms, multiply these things out. And so now these two things here are actually like terms. So we're going to have this 3 cosine squared theta. And then 6 minus 1 is a plus 5 cosine theta minus 2. And that would be the answer to that thing foiled out. So the first couple questions you're going to have in varsity on 7.1a are actually going to be these foiling questions. So it's going to give you some experience doing that. Okay. You're also going to see a question where it's going to say something like sine of theta minus 2 squared. Remember that this means that there's 2 of these. So you're going to write that twice. Sine of theta minus 2, get rid of this, and FOIL. Don't just square the first term, square the second term, and be done. That won't do it for you. So make sure you write it twice and FOIL. Okay, I'm not going to actually do that math. You don't need me to do that. All right, so we're going to have a long section here on factoring. And so what I'm going to do is remind you of factoring with a numeric example, and then I'll do one with a trig example. If you don't remember how to, let's say, factor by grouping, or factor a trinomial, or factor with difference of squares or sum of cubes or something, I will post the videos that I do for my Algebra 2 classes in kind of a review material type of post in Google Classroom, and you'll have those to reference. So if you need some reference material, if you need to go back and review those, you're going to have to do that on your own time. I'm not going to reteach that here, but I will go over it quickly. So hopefully it'll be enough to remind you. So here is a factoring review. All right, so we'll start with a GCF factoring. Remember, that stands for greatest common factor. Let's say we have 6x squared y minus 9y, or xy squared minus 21xy. Well, you want to look for the largest number and or variable combination that can come out of every single term. And in this case, they're all divisible by 3. You have an x in every single term and a y in every single term. After your GCF goes an open paren, and then essentially you're dividing each term by the GCF. So what's left over? Well, 6 divided by 3 is 2. We have an x left over out of there. Then we're going to move on to the next term. We have a 3. We have a y left over out of there. Move on to the next term. We have a 7 left over and no variables. And this is what the factored form would look like. All right, well, that can happen in a trig example as well. So let's say you have secant squared x tangent squared x plus secant squared x. Well, in there, we have one term here, the secant squared, tangent squared. Those are attached by multiplication, so it's one term. And then we have secant squared. So we can take a secant squared from each of those terms, and that leaves us, out of the first term, a tangent squared x, and then a 1, because we took the secant squared out of here, but we have a 1 left over, right? And you can re-multiply and get what you had left over. And that would be the factored form of that. But the directions say to factor and simplify. And the more of these you see, the better off you're going to be. So remember that with the Pythagorean identities, that tangent squared x plus 1 equaled secant squared x. So this, by an identity, is secant squared. So this is still secant squared, this guy. And this is also secant squared by a Pythagorean identity. And so if you multiply those together, secant squared times secant squared is secant to the 4th. And that would be that guy simplified. So that's an identity actually worked out using factoring. That's the idea of kind of where we're going. So the more of these, again, you see and I do, the better off you're going to be. All right, factor by grouping. Numeric example. Let's start with 4x squared plus 12x minus xy minus 3y. Remember that in factor by grouping, you start by putting two terms together in a set of parentheses. Then you separate with a plus sign. And then you factor a GCF out of each one. So I can take a 4x out of here. That leaves me an x plus 3. I can take a negative y out of here, which leaves me an x plus 3. Recall that these quantities have to be identical in order to continue with GCF or grouping, And so that x plus 3 comes out front, and the two GCFs left over go into the second set, and that would be the answer to that factor by grouping problem. All right, well, we can do essentially, again, the same thing with trig functions. And so here is a factor by grouping with trig. So we're going to start with secant cubed minus secant squared minus secant minus 1. Nope, plus 1. All right, and again, the directions say factor and simplify. So I'm going to put my secant cubed minus secant squared in one set of parentheses, plus the negative secant, plus 1, and then factor out a GCF. So in the first quantity, I can take a secant squared out. That gives me a secant x minus 1. Now this leading term's negative, so I'm going to pull that negative out. I'm not taking a secant out, I'm just taking a negative 1 out. All right, so we're taking a negative 1 out because that's all we can do here. So that changes the sign on both of these. And so now in my next step, I have secant squared x minus 1. That's my common, my GCFs, and then I have secant x minus 1. And if you recall, again, from the Pythagorean identities, I can take, I don't remember which form of this you had, but 1 plus tangent squared x equals secant squared x. And if I remove the 1 from both sides, I now have tangent squared x equals secant squared x minus 1. So secant squared x equals tangent squared x. So I'm going to change this into tangent squared x, because anytime you can turn two terms into one, that's preferable in a trig function or trig identity. So you want to do that. And this guy doesn't have a squared. So these Pythagorean identities all have squareds on them, right? So that's something you want to be looking for with trig identities. And this is just going to stay a secant x minus 1. And that's about as simple as you could probably make that. So we're going to just leave that looking like that. Okay. All right. Let's go on to factoring a trinomial. I think I'm going to go to a new screen. Factoring trinomials. Remember, a trinomial is in the form ax squared plus bx plus c. But if you've done much of this, you really should know that the exponents here, as long as this one is double, so the first one is double the second one, you can factor a trinomial anytime. Okay, so this could be a 6 as long as the second one's a 3. This could be a 1 as long as this one's a half. It's just that this first one has to be double the second one. And those can always be done that way. So first one we're going to do is 6x to the fourth plus 5x squared minus 4. So I use what I call X method in my classroom when I teach these. And so we make a big X. We put A times C in the top, B in the bottom. And so A times C here is negative 24. The B is 5. And then we look for factors that will multiply to the top and add to the bottom. 8 and 3 will multiply to 24. And to make it negative, we have to have one be positive, one be negative. And then to make them add to 5, the 8's got to be positive and the 3 has to be negative. And then we divide by the A term and reduce. And we're going to use these to turn into our binomials. So the bottom comes up and gets a variable. So this is 3x plus 4. Bottom comes up and gets a variable, 2x minus 1. And that is how the factored form of that trinomial looks. All right. Well, let's do a trig example. We're going to start with cosecant to the fourth of x minus 2 cosecant squared x plus 1. All right, well, there's not a lot of numbers in here, but here's my x. My a is 1, my c is 1, so that's 1. This is negative 2. Well, 1 times 1 is 1. They both have to be negative to add to negative 2. And we're dividing by 1. Oops, dividing by 1. So the 1 comes up. And so I'm just going 1 cosecant x minus 1. And again, 1 cosecant x minus 1. And because this is a 4 and this is a 2, these each need to be squared. Oh, I missed that up here. Excuse me. That's a 4 and that's a 2. So these guys always get the power on the b term. Always. Okay, so they always get the power on the b term. So that is how you would factor that trinomial. All right, difference of squares. I know this is a lot really fast, but you guys should be good at factoring, so should be. Difference of squares. The example numerically, 16x squared minus 121. That factors into 4x minus 11 and 4x plus 11, right? You're taking the root of each of these, and then you got one is positive and one is negative. That's all that's happening there. It's not a big deal. Same thing is going to happen if you have trig functions. So let's say we have cosine squared x minus 4. Well, that will factor into cosine x plus 2 and cosine x minus 2. Okay, if you had a coefficient out here, let's say 25 cosine squared x. This will be a 5 cosine x and a 5 cosine x. Okay, that's all that would happen with that. All right, and the last one of these I want to talk about is difference of cubes. And then we have something briefly so that you can finish the varsity assignment. So difference of cubes. I don't know if you remember the formula. It starts out looking like a cubed minus b cubed, and you factor it into a binomial and a trinomial. That should be a squared. So it's a minus b times a squared plus ab plus b squared. And if you had the sum of cubes, the only thing that's different are the first two signs. Okay, so the first one's difference, the second one is sum. And here's a numeric example. If you had, for example, 64x cubed minus 125, you're taking the cube root. If you don't know how to do that, come see me. But the cube root of 64 is 4, and the cube root of x cubed is x. So this would be 4x minus the cube root of 125 is 5. That gives you the binomial a minus b right here. And then essentially you're using that. That's not going to fit in there. You're using that to expand out your trinomial. So a squared would be 4x times 4x would be 16x squared. Follow the formula and use the right signs. So a times b is going to be 4x times 5 is going to be 20x. And then b squared is 5 squared, so that's 25. And this would be the factored form of 64x cubed minus 125. And if you were in my Algebra 2 class, I would make you FOIL all that back out again and see everything that's going to disappear. And you do end up getting these two terms back. It's a whole bunch of things that disappear out of those. So that's how you do that. All right, let's see what we would get if we had a trig function where we were going to do this. So let's say you were going to factor 8 tangent cubed x minus 27. Well, the cube root of 8 tangent cubed would be 2 tangent. So we would get 2 tangent x, and the cube root of 27 would be 3. So we would have that. And then if I square 2 tangent, I would get 4 tangent squared. So 4 tangent squared x. Then I multiply these two things together. So 2 tangent times times 3 is going to be 6 tangent. And then I square the 3, so plus 9. And that's what I would get if I were factoring that guy out. All right? I'm not going to do a sum of cubes. It's exactly the same thing, just different signs. All right. The last thing you need to be able to do, you're going to see a problem in varsity that is going to look like this. Simplify the root of 36 minus y squared as much as you can, well, as much as possible, after substituting six sine x for y. Okay, so I want to just walk you through the steps to do this to make sure the math isn't terribly difficult, but if you need it modeled for you one time, I just want to make sure that that happens. All right, so we're going to take the 6 sine x and put it right there. And so here's how this is going to look. 36 minus 6 sine x, and we're going to square that. So if you square 6 sine x, you're squaring both things inside the parentheses. So that's going to be 36 minus 36 sine squared x. And so what we can now do, you can drop the parentheses, 36 minus 36 sine squared x. All right, well now if you see a common factor like that, you should always think GCF. Okay, so now I'm going to factor the GCF out. So 36 times, this becomes a 1, minus sine squared x. And anytime you see a squared on a trig function, you should be thinking Pythagorean identity. Okay, and 1 minus sine squared x is equal to cosine squared x. Again, from the Pythagorean identity, sine squared plus cosine squared equals 1. So some manipulation will get you there. So this is 36 times cosine squared x. And now if you take the root of that, well, the root of this is essentially, because they're multiplied together, the root of 36 times the root of cosine squared. Well, the root of 36 is 6, and the root of cosine squared is cosine. And because of this, you don't really know if this is a positive cosine or a negative cosine, right? And this is true. Cosine times cosine is cosine squared. And negative cosine times negative cosine is also cosine squared. And you don't know which one you're dealing with. So in varsity, you need to put some absolute value signs around your cosine x so that it does not get marked wrong. Okay? That's the last couple problems, I think, in this problem set. So, all right, that's the beginning of trig identities. 7.1b will be more manipulation of them using the reciprocal functions and Pythagorean identities and that kind of stuff. All right, well, toodaloo.